Good morning, grade 11s. Welcome to Tuesday, May the 12th. Hope you had a good day yesterday working on your assignment. I'm going to go over a few of the questions from it based on a couple of questions that I received. But before we get to that, I want to give you your verse of the day today. It comes from Colossians 3, verse 17, where it says, "And whatever you do, whether in word or deed, do it all in the name of the Lord Jesus, giving thanks to God the Father through him." So there you go. Whatever you do today, whether in word or deed, do it all in the name of the Lord Jesus. And give thanks to God the Father through him. All right, so moving on. We gave 5 questions yesterday in your handout that was on Connect. And I'm going to go over a few of them, certainly not all of them, because they're all kind of done the same way. But let's start by going over question number 1. So question number 1 on the assignment says the following. And again, you have the paper in front of you. Feel free to pull it out. It says the first resonant length in a closed air column occurs when the length is 30 centimeters. What will the second and third resonant lengths be? All right, so the first resonant length in a closed column is 30 centimeters. Now remember, when we have a closed column, the first resonant length happens when it looks like this. Right? I remember from our diagram that we had the other day, this was going to equal to 1/4 of the wavelength. Well, this question is telling us that this length here, this first resonant length, is happening at 30 centimeters. Well, that means that that 30 centimeters is equal to 1/4. That's not how you write a wavelength. 1/4 of the wavelength. And so if 30 is 1/4 of the wavelength, then we want to find the second and third resonant lengths. So the first thing we're going to do is we're going to find the wavelength. So what's the wavelength here? Well, multiply both sides by 4 and we get 120 centimeters equals the wavelength. When we did our diagrams on the board yesterday, we recognized that there was a half wavelength between resonant lengths. And so you can do this in a couple of ways. If the first resonant length happens at 1/4, that means the second resonant length is going to happen at 3/4 of the wavelength, which in this case would equal to 3/4 of 120, which would equal to the 90 centimeters. That is the answer. Okay? And then the next resonant length, the third resonant length, is going to happen again a half wavelength further. So we can do this, 5/4 of the wavelength. So 5/4 of 120 is going to equal the answer of 150 centimeters. Okay? Simpler way to do it just by adding, since these numbers are pretty simple. If the wavelength is 120, that means that half that wavelength is 60, and resonant lengths are a half wavelength apart from each other. So if the first one is at 30, and the half wavelength is 60, 30 plus 60 is 90, 90 plus 60 is 150, means the next one's going to be 150 plus 60, and so on for all the resonant lengths. Okay, so that's question number 1. You can pause the video here to make sure you've got the answer down. I'm going to quickly erase it and do question number 3. Okay, so question number 3 says the following. Question number 3 says, what is the shortest air column closed at one end that will resonate at a frequency of 440 hertz when the speed of sound is 352 meters per second? So we're given a frequency, we're given a velocity, and resonant length, the first resonant length in a closed column of air is going to happen at 1/4 of the wavelength. So if I'm given frequency and velocity, I need to find wavelength. Fortunately, we have a formula for that. Our universal wave equation, velocity equals frequency times wavelength, which means the wavelength equals to the velocity divided by the frequency. The velocity was 352 meters per second. The frequency was 440 hertz. and that equals to 0.8 meters. And again, that's the wavelength, the first resonance, so the shortest column of air that would be needed is going to be 1/4 of that, because the first resonant length happens at 1/4 of the wavelength. So 1/4 of 0.8 meters is 0.2 meters, or 20 centimeters, as the book has the answer. All right, so again, closed length. First resonant length is at 1/4 of the wavelength. Subsequent resonant lengths are a half wavelength further along. All right, moving on to the next set of questions. There was 2 questions on open column resonance, and I'm just going to again do the first question there. The second question is done almost exactly the same as this question, except remember that the first resonant length of an open column happens at 1/2 the wavelength. A closed column is 1/4 of the wavelength, and an open column is 1/2 the wavelength. But otherwise it's done exactly the same. You're going to find the wavelength, and then you're going to find the resonant length that's required there. Let's do question number 1 in that second set of questions. Okay, so second set of questions, it's a number 1 again, and it says the second resonant length of an air column that is open at both ends is 48 centimeters. Determine the first and third resonant lengths. All right, so when we drew these the other day, our first resonant length was a half wavelength. And then again, the open and closed, it doesn't change this. The subsequent resonant lengths are a half wavelength apart. So if the first resonant length happens at a half wavelength, let me just write this down. The first one happens at 1/2 the wavelength. The second resonant happens at the wavelength, and the third resonant length would be at 3/2 the wavelength. Well, the question's telling us the second resonant length is 48 centimeters. Well, lo and behold, that is there. So now we can go up and down, right? If 48 is our wavelength, well, half the wavelength is going to be 24. And 3/4 of the wavelength, 48 times 1.5, is our 72 centimeters. All right. And for each subsequent one now, if we wanted to find the fourth resonant length, it would be 72 plus 24. Each resonant length is half a wavelength away. All right, so those are the answers to the questions. Again, if the 2 number 2s that I didn't do, if you have questions on those, feel free to ask, and I can cover those in a later video if need be. But again, the question 2 on this one is exactly the same as question 3 from the first set of questions. All right, that's pretty much it for today in terms of new content. What I'm going to do is you're going to get a little bit of you're going to get an assignment out of your red textbook, your textbook, so you can look on Connect for that. It'll be 4 more questions dealing with the same kind of stuff. And then actually what we're going to do is we're going to move into some review stuff in the next couple of days on the things that we've looked at already in sound waves. So you can look forward to that. And then, as I think I mentioned a couple days ago, we're heading towards a test on sound waves, which should be coming soon. So be aware of that and be ready for that as it comes in the very near future. Have a great day. We'll see you tomorrow.